Hey everyone, we are doing 2024 Level 2 Calculus today. Like yesterday, I'm gonna solve them really fast. I already solved them and I'm just gonna explain. Okay, question 1a. A function f is given by f of x is this. Use calculus to find the gradient of the graph of the function at the point where x equals 2. It's an easy question. So you differentiate as I did here, right? I'm going to underline here, right? And then you just plug 2 and you will get 29, right? Next, B. For the function f is f prime x is this. The graph of f of x passes through the point 2, 36. Find the equation of the function f. So you have to integrate, isn't it? So this shows how you integrate the gradient function, right? And you have C, and then you plug 2 into this original function and set this be 36 to find the C, right? So C turns out 4. So hence the equation is like this 2x cubed minus 2x squared plus 12x plus 4. That's the answer. Next, a curve is given by that using calculus method 1. Find the x-coordinate of the local minimum. 2. Explain how you know this is a minimum point. So, well, to find either maximum minimum, local maximum minimum, you have to differentiate, right? So that's what I did, and that is 0. So I divide by 9 on both sides, make it easier, and then factorize it. So it turns out x equals negative 1, 3. If we use algebra to find which one is, you know, minimum and maximum, it's actually easy because this is a positive cubic graph, so it would look like this. So the first one of here is negative 1. The second one is 3, right? However, it says use calculus. So you got to differentiate again, right? Second derivative. And then you have to test whether it's a local maximum or minimum. So, second derivative is 18x minus 18. And then you plug negative 1 first to test. So it turns out negative, meaning it's a local maximum, isn't it? But we are finding maximum. We are finding minimum. So when you plug 3, we get positive. That means that this is local minimum. And then I summarize. When x is 3, we get local minimum. Okay. All right. Question D. Right. A drink manufacturer would like to start a new line of cylindrical cups that are designed to keep hot liquids warm for as long as possible. So like this, they would like to the cup to hold a volume of 500 ml and be cylindrical in shape. Calculate the dimensions of the cylinder, right? So, well, volume of cylinder is this, and A equals to 500. So that's a constraint. Using this, we have to unify the variables. Yeah. So because you have two variables here, R and H, you can't differentiate. So from here, I can set H equals 500 over pi R squared, and then I can change, surface area. So this is in terms of R, isn't it? I even changed 1000 over R to be 1000 R to the power of negative 1. You know why? So it's easier this way to differentiate. So dSA over dr becomes that and equals to 0. And then we found R to be cube root 250 over pi, which is 4.3. Well, I suppose this should be centimeters, but I just play safe. So I just said a units, right? Because it didn't I think they forgot to say, the unit, but anyway, that's fine. 4.3 units. Hence, H must be 8.6 units, right? Next, the graph of function is shown the axis below and sketch the graph of the gradient function. So you differentiate this. So what you have to show is, that stationary point or turning point should be x-interception. So you have to line them up. So when x is 0 and that, right, should be 0 x-interception. You know, and then yeah, because it's parabola, so it's symmetrical. So I found that the middle point to be turning point of the gradient function. Yeah, it looks very sharp, but it doesn't really matter as long as you show x-intercepts here, and then this is a negative graph, isn't it? Negative cubic, so that's why it's upside down parabola. So two things, uh, turning points, matching turning point, and then uh, you know positive or negative. Then you get a full mark on this question. Question B: find the equation of the tangent to the graph of the function f of x at the point at negative 2, 3. So obviously you have to find the gradient. So f prime x is that, and when you plug negative 2, you get 24. Unusually really sharp tangent, isn't it? Y equals 24x plus c. To find the c, you have to plug negative 2, 3 to find the c. Turns out 51. So your the equation of tangent is this. All right, question C. So I want you to read this. I'll give you about 10 seconds so that I can have a rest. All right, question 1 says, what is the rate at which the population is decreased on day 10? So because it's asking the rate, that means you have to differentiate, right? So P prime T equals that, and you plug 10. So it turns out negative 132. I just made a unit, so minus 132 per day. You have to say increase, right? But you don't have to say this because it says decrease, so minus showing is decreasing. Question 2. Use calculus method to determine the difference in bacteria population size from the time all the nutrients in the Petri dish had been used up to the time the microbiologist added more nutrients. So if I draw this cubic graph like this, right? So it's easier to understand. So that's the maximum and minimum. So the scientists feed the bacteria again from that moment, right? So you have to find that moment, and you find the difference. So that local maximum turns out 8, and minimum turns out 32. So then plug 8 into the original function population. That is 43,776. And when t is 32, 36,864. And you find the difference. It turns out 6,912. It looks a bit ugly, but yeah. Question D. A trapezium is drawn within a parabola given by y equals 8x minus x squared and x-axis, such that the two parallel sides are positioned at x and 2x as shown in the graph below, where x is in between 0 and 4. Now, given that the area of trapezium is given by A equals that, it's the formula for trapezium is where A and B are the length of a parallel sides, and H is the perpendicular distance between them. So it's a height talking about. Use calculus to find the maximum area of the trapezium. So we have to find A and B, right? So A and B are Y values. So you plug X into that, so 8x minus x squared. So the reason why I factorized, I just want to know how much that is, 8, right? When you factorize it. And half, um, so that is A, I believe, and that is B, and times by height, which is X. 2X take away X is X, right? And then you simplify and expand, you get that. And dA dx, you have to differentiate to find maximum, isn't it? Yeah. So you differentiate and find the, when it happens, I mean, equals 0. When x is 0, which is nonsense, x can't be 0, or 3.2. So 3.2 must be right. And then you plug 3.2, don't forget, because the question asks you to find the maximum area, isn't it? Right here. Where is it? Yeah, find the maximum area. So you have to find the area. So you plug 3.2 into where this equation, I suppose. Yeah, 12 times 3.2 squared minus 2.5 times 3.2 cubed gives me 40.96 units squared. All right, question 3. A function is given by that. Find the coordinates of the point on the graph of this function where the gradient is equal to 3, each question. So you differentiate the h of x and just set this one to be 3, right? So it turns out x is 10. So when x is 10, the gradient is 3 means. So you plug 10 into original function to find the y value. Turns out 9. So 9 comma 10 comma 9 should be the answer. Question B. A truck is waiting at the red traffic light. When the traffic light turns green, the truck begins to accelerate at 0.64 meter per square second until it reaches its top speed of 25 meter per second. Use calculus to find the distance the truck traveled until it reached its top speed. So this is kinematics question, right? So to find the velocity, so you have to find the velocity first and then find displacement function. So you have to integrate acceleration, right? You get that, and it turns out c is 0 because when time is 0, velocity is 0 because it stopped. The truck stopped there. So c is 0. So I got this velocity function over there. And before I do displacement function distance, I found how long it takes to reach 25 meter per second. So simply, I equate that, right? 0.64 t equals 25. So t turns out approximately 39 seconds. So then I carry on to find the s of t, and I integrate the velocity function, and still you get c, right? However, again, the reference point when time is 0 is 0. So c must be 0. And finally, I got this displacement function. And then I plug 39 seconds, right? To find the distance of 486.72 meters. All right, question C. So find equation for f of x which passes through 1,0. Knowing that this line is gradient function, so obviously you have to find the equation first. This is c, right? So which is 1, and then you find the m, 1 up and 2 across. So that's how you get 1 over 2. So you integrate that, you get c obviously, and then you have this information. It passes, f of x passes through 1,0. So when you plug 1, you get 0. So it turns out C is negative 5 or 4. So you complete this equation. So that should be the answer. Now, draw the graph. This is kind of a new question this year. Now, draw the graph of f of x, right? So, what do we know? So this is the graph we have to know. When x is negative, yeah, here you see when x is negative 2, that's the x-intercept. So x-intercept must be the turning point. So when you plug negative 2, you get negative 9 over 4. That's the turning point. And then the x-intercept of the original function, oh, by the way, negative 5 over 4 must be y-intercept, right? Right here. And remember, it passes through 1, 0. So that's the information. So 1, 0 here. And because it's a parabola, it's got to be symmetrical. So 3 units from the center and 3 units from the center. So that must be negative 5, right? So these are 3 points, key features, and join them together to draw nice upright parabola. Okay. Question D. If y is k minus x, where k is number, use calculus to show that the minimum value of x squared plus 2y squared is equal to that. So I just named this is a because we are going to differentiate this expression, right? So x plus 2 instead of y, I plug that in to unify the variables, right? Expand, right? Expand, and then we should be able to differentiate a. So dA dx becomes a 6x minus 4k, and it says minimum value. So because it's turning point, it should be equal to 0, right? So that way, I find out what x is when it happens, minimum value. So when x is 2k over 3, we have to find the y value. So obviously, we have to plug 2k over 3 into an original function a. So then you will find 2k squared over 3. Right? Awesome. Okay. I hope you did well in calculus, and I will see you next time. Bye.